Okay, in this part of the problem, I'm just going to continue on from this and I'm going to calculate the final velocity. Okay, bear in mind that we estimated using a simulation the last time that it would be about 7.3, I think, meters per second, but I think I might be wrong. Okay, so what we do here is to calculate the final velocity. Well, we already worked out the change in momentum. The change in momentum was a positive 250 kilogram meters per second. Okay, so instead of using this side of the equation, I'm now going to concentrate my efforts on this side of the equation because I want the final velocity here. I know the initial velocity here. This is what I'm after. And we know what the mass is. So I've got all these variables here. I also have this one. Okay. So I'll go ahead and do that. So my change in momentum is 250. Sorry, that's not a good color. 250 kilogram meters per second. And that's equal to the mass times the final velocity. So it was 50 kgs times v final, velocity final, minus 50 times the initial velocity, which was 0. Okay, now this 50 times 0 is just gone. So then I'm left with 50 times the final velocity equal to 250 kilogram meters per second. Of course, this is a mass in kgs. Okay, that's 50 kgs over there. So now what I do is I simply divide both sides by 50 kilograms, and that leaves me with 250 kilogram meters per second divided by 50 kilograms. The kilograms cancel, and I'm left with a velocity or a speed of 250 divided by 50, which is 5 meters per second. Please notice that the meters per second is the only thing that's left after we cancel off that kgs. So the final velocity is 5 meters per second, and also notice that it is positive. Okay, so it didn't turn out to be negative because the velocity turns out to be going to the right. Now, what I decided to do is try redo this. I know I have to apply a force of 50 newtons to my box of 50 kgs for a time of 5 seconds. So to try help me do this a bit better, I have got an online stopwatch here. Let's see if I can do this right. Okay. Actually, maybe instead of... Okay, what I've done here is I've just reset the stopwatch to just a counting timer. So I'm just going to start it now. I'm going to wait until it gets maybe 5 seconds, and then I'm going to hit, maybe I'll go from 10. So I have to apply the force for 5 seconds. 1, 2, 3, 4, 5. Okay, not bad, not bad. Okay, I got to 5.5 meters per second was my time, and my calculation said that I should have got 5 meters per second. So I didn't do too bad. Still, that's just down to do with my own reaction time to be able to press the buttons on these things. So what I'd like you to do now is go ahead and try practice problems that I have assigned underneath here. And when you do it, I want you to use the simulation that is at the top of this page. It's over here on the right, that forces of motion acceleration, forces of motion basics, and it's the acceleration game that we use. Okay, so you'll see down the bottom, I can't really navigate down to it right now, but you can hopefully see, oh, I can, here we go. So you can see there at the bottom, you've got net force, motion, friction, and acceleration. If you go to the acceleration game and play around with it there, then you can basically turn on all of these parameters, and you can apply a force and measure the final speed up there. Okay, so best of luck with that, and make sure that you post your work